Hi, my name is Bhaumik Patel and I am presenting reverse engineering UML diagram. Reverse engineering of behavioral models consists in extracting high levels models that help understand the behavior of existing software systems. An approach for the reverse engineering of sequence diagram from the analysis of execution traces produced dynamically by an object-oriented application. Our approach is fully based on dynamic analysis and reuses the Catal merging algorithm to produce a label transition system that merges the collected traces. LTS is then translated into a sequence diagram which contains alternative and loops. The overview for the project is the reverse engineering can be done statically by analyzing the system source code or dynamically by running the program and then analyzing the obtained execution traces to extract sequence diagram. The dynamic analysis is better suited to the reverse engineering of sequence diagrams of object oriented systems. The reason after that is the inheritance polymorphism and dynamic binding. Indeed, it is difficult to know the dynamic type of an object reference and which methods are executed by only relying on the source code. An execution trace of an object-oriented system is defined as the sequence of method invocations where each method invocation represents a communication between two objects. Here is the diagram of reverse engineering of the software. Regarding the diagram, the mapping between the method invocation and traces and messages in sequence diagrams is straightforward. Two major challenges can be identified from the diagram. First is control flow detection. The first challenge concerns the detection of controls structures in traces and their mapping to interaction operators in sequence diagram. This mainly concerns the detection of the two main interactions with operators included in UML sequence diagram, alt and loop. The second is multiple execution traces merging. The second challenge concerns merging execution traces. Indeed, the behavior of a system is often described by multiple execution traces that correspond to different scenarios. Background and approach. The goal is to extract UML sequence diagram from multiple execution traces for an object-oriented system using only dynamic analysis. The dynamic analysis is better suited to reverse engineering of sequence diagrams of object-oriented systems because of inheritance polymorphism and dynamic binding. To formalize the reverse engineering of UML sequence diagram, we need to define following methods. Execution traces for object-oriented system. Performing dynamic analysis uh, of an object-oriented system starts by collecting an execution trace from its execution. An execution trace is defined as a sequence of method invocation. Now this slide is regarding approach continuation. uh, Sequence diagram. A sequence diagram shows how a set of objects interact with each other. The diagram is considered in the following. Prototype implementation. The architecture of this prototype is organized into 5 components, which are described below. First component is execution trace collector. This component is responsible for observing the running system. Uh, to be able to perform this observation, this component uses a customized debugger to collect execution traces for Java systems. This component captures the execution traces and builds the related LTSs. The mapping from execution traces to LTSs was implemented as an M2M transformation. The second component is LTS merger. The component takes the LTSs generated by the previous component as input and merges them into the single LTS.